Hey everybody, this is Mr. Longo, and in this video we are going to cover geometric sequences. So basically to start, I just want to give you a little heads up that a geometric sequence is where we're multiplying to get from one term to the next instead of adding or subtracting like arithmetic. So in general, it's to find a term, it's just the rate times the previous term. This would be like our recursive function. And the rate is just, the term that you're on divided by the previous term, similar to common difference. It's the term minus the previous term will always give you your difference. But we're going to do stuff more powerful than that, which is why we have a formula. And it's a sub n is equal to a times r raised to the n minus 1. Remember, if it's just a that represents the first term, the same thing as a sub 1. So we're going to skip right to the fun problems that we were doing earlier with arithmetic sequences. We're just going to use some rates or multiplication instead. So for number 1, we have the beginning of a geometric sequence, and we want to find what the 8th term is. Again, you can just keep on pressing times the rate in your calculator till you get to the 8th term, or we could just be smart about it and use our rule. So, to get from 5 to 15 and 45, or 15 to 45, we're just multiplying by 3. Again, 45 divided by 15 is 3. 15 divided by 5 is 3. That's how we're coming up with our rate. Or you can just think about it. So to find a sub 8, we need the first term, which we know is 5, times the rate, which we now know is 3, raised to the number of term minus 1. So we're looking for the 8th term, so 8 minus 1 is 7. And now all we're going to do is pretty much type that in our calculator and find out that the 8th term is going to be 10,935. All you have to do is 5 times 3 to the 7th power, and you are good to go. So again, you could have just multiplied by 3 the whole time, but that would take a lot longer, especially if we were doing something like 8 to the 27th power. Number 2, this one we can see is getting smaller. 2 divided by 6 is 1/3. 2/3 divided by 2 is 1/3. So this is dividing by 3, but still multiplying by 1/3, which would be our rate. So to find a sub 6, we have our first term, which is 6. And we know that the rate is 1/3. And we're going to raise that to the 5th power. Again, your graphing calculator can just do this for you. All you really have to do is type 6 times 1/3 to the 5th power, and it will give you the answer. But when you work with fractions, your calculator is going to give you a big nasty decimal, which you can, of course, change to a fraction. But sometimes it doesn't always work. So I'm just going to show you what you could do is 6 times 1 to the 5th power is still 1, and 3 to the 5th power is 243. And then you just multiply by 6, reduce your fraction, and you're going to get that a sub 6 is equal to 2 over 81. The reason why I say that is because if your fraction gets too big, sometimes your calculator can't handle it. So if you just do it step by step on your own, you'll be able to have a fraction instead of a big, ugly decimal. Okay? So moving along, the next example I'm going to let you try. The one thing I'm going to tell you about this example is you have to go back and find a sub 1. And then number 4, you're just writing the rule. Similar to the rule that we've been using, a sub n, you're going to write the formula for a sub n using what's given there. Again, a sub 3, hint is you have to find a first, or a sub 1 first. Okay? Why don't you pause the video, give these two a try, and click play when you're ready to see, and we'll be good to go. Okay, so for number 3, we have a sub 4, which is 12. That's equal to, as I mentioned, we don't know what a sub 1 is. We know our rate is 2. And if this is the 4th term, 4 minus 1, we're going to raise to the 3rd power. So that's just going to give us 12 is equal to a times 2 to the 3rd, which is 8. Divide both sides by 8, and we will have that a is equal to 1.5, also known as 3/2. However you wrote it is fine, because now we're going to use that to find a sub 3. So, to find a sub 3, all we're going to do now is a sub 3 is equal to the first term, which we now know is 1.5. Our rate is 2, raised to the 3 minus 1, aka 2 power. And 2 squared is 4 times 1.5. That's going to give us a sub 3 is equal to 6. Okay, and that's what we got going on for that one. Which would make sense, because now after that, if you multiplied that by 2, you are going to get 12 right back to the fourth term. So if you were slick enough, you could have figured out that that was 6, because if you would have just divided 12 by 2, that would take you to the previous term of 3. Write a rule. That means a sub n is equal to a sub 1 times your rate raised to the n minus 1. All you have to do is say that a sub n is equal to your first term, which is 2, your rate, which you can see is a negative 2, raised to the n minus 1. So if ever you're asked to write a rule or a formula of how you would find a sub n, that's all you have to do is plug in the necessary information to the formula. Okay, and that's it for this video on geometric sequences. This is Longo and I'm out. See you, bye.